Welcome back to another video. So in this video we are going to talk about Azure Traffic Manager. So this is a DNS based global traffic distribution and load balancing solution from Azure. And before jumping into this video, I would highly recommend to check out the video which I created on DNS. So there are two videos. I'll link those video so you can check them out by clicking the I button on top right corner, or I'll add those in description as well. So with that being said, let's quickly jump into the topic. So I'm today going to talk about this Azure Traffic Manager. So what is Azure Traffic Manager? So it is a DNS based traffic load balancer that distributes traffic across global endpoints to optimize performance, availability, and resilience. And it provides core functionality like DNS level routing and high availability and global scale. And we are going to talk about these points in detail in later part of this video. So let's see how it works. So whenever user request any domain, for example user request google.com, then browser ask recursive DNS resolver, and DNS resolver queries traffic manager, which evaluates endpoint using different routing methods and health probes. Okay, so different health proofs. So once it get the DNS response via traffic manager, and it can return any of DNS records like CNAME, A records to the resolver, and then client can directly connect to the endpoint, and traffic never flows through the traffic manager. Okay, so how this looks on architecture level. So for example, this is user which is requesting this app.consider.com. uh, DNS query reaches to DNS resolver, and it basically checks with the Azure Traffic Manager. So we have two options here. Either we can directly return on the best endpoint to the user and skip whole this part, or we have the solution. So what Azure Traffic Manager does is it does all the um, logic part of finding which endpoint to pick based on different mm, approaches. Like in this case it is picking based on priority. For example, this is primary, this is failover, and this is again a failover. So it will check if the primary is healthy, it will return the IP of primary. Otherwise, if it fails, then it will make these primary and return the IP of this. So if you see, traffic manager is not a proxy. It only resolves DNS queries, and actual application of traffic flows directly from client to the selected endpoint, ensuring zero latency added. So kindly, it is just managing the traffic. Its traffic is not going through it, something like that. So it do not introduce any hops to the DNS lookup and all. So these are some common key features. It provides six routing methods: priority, weighted, performance, geographic, multi-valued, subnet. It checks health via configurable intervals and automatic failovers. It also supports nested profiles. We can combine different routing method for sophisticated multi-layer routing logic, hybrid connectivity, route to Azure, external on-prem, and run seamlessly. We can also view traffic action level insight into user traffic patterns and DNS resolver locations, and it is resilient by design as well. So it survives entire Azure region failures with automatic endpoints. So now we have come to different routing mechanism used by traffic manager. So first one is priority. It is also called active passive failover. So how it works? Different endpoints ranked by priority, one being highest, and all traffic goes to this primary endpoint. Uh, Common use cases are disaster recovery, primary backup configuration, maintenance in window, and failover activates backup endpoints automatically when health probe detects a primary failure. So, for example, we have primary and backup two servers endpoint added to our traffic manager, and we are using this priority based routing mechanism. Then it automatically checks for the health. If primary is unhealthy, it will automatically redirect traffic to failure. Second one is weighted. So in this traffic distributed across endpoint based on associated weights, where weight value can be 1 to 1000, and it can be used for canary deployment, gradual rollouts, balanced load distribution. For example, I have two servers A and B, and I want to distribute maybe equal load, or I can assign 50-50 values for both, and traffic will be distributed equally. Next comes the performance or low latency. So it uses internet latency table to route users to the endpoint with lowest network latency. And common use cases are global application require fast response, CD, content delivery optimization, multi-region deployments. So latency is based on DNS resolver IP location, not the end user directly. It uses Microsoft Anticast network. Next is geographic based routing. Router users to a specific endpoint based on the geography of origin of the DNS query. And the common use cases are data sovereignty, regular compliance, content localization, regional traffic management. And it supports 70 plus geographic region, enables geoenforcing for compliance with data resiliency and regulation. Next are multi-valued and subnet routing. So it return multi-values for healthy IPv4 and IPv6 endpoint in a single DNS response. So a client can try alternate IP first fails, something like that. And subnet is maps specific user IP address ranges to designated endpoints. For example, office space routing for enterprise using user granular based IP traffic control, etc. Next is health monitoring and endpoint types. So first is Azure endpoints. So we can add in our profile the Azure endpoint like app services, VM, cloud services, public IP, external endpoints, any public DNS name or IPv4 or IPv6 address in our traffic manager. Another is nested endpoints, other traffic manager profiles for complex routing. And health probes, so it supports protocol like HTTP, HTTPS, TCP, and standard interval is 30 seconds, fast interval is 10 seconds, add-on and automatic failover on probe failure. Okay, so architecture and configuration. So this is, I think, the part where how can we set up traffic manager. So we can go to Azure portal, create a traffic manager profile, choose a routing method. We can configure DNS name. For example, we are creating app.trafficmanager.net. We can add endpoints like Azure services, external endpoints, or nested um, traffic manager profiles as well. The next step is to configure health monitoring probe and intervals, set TTL values for DNS caching behavior, map custom domain via CNAME to the TM profile. Once this is done, we are good with TM. The final part is best practices. First is use nested profiles combine routing method for complex plus global region routing strategies. So this is the case for complex routing mechanism where we can combine multiple routing methods according to our needs. Next is configure fast health checks, enable 10-second probing for mission critical application to minimize failover time. Optimize TTL setting, lower TTL 30 to 60 seconds for faster failover, higher TTL to reduce DNS query cost. Leverage traffic view as traffic manager provides traffic view, then we can utilize this as well. Um, Test failover regularly, simulate endpoint failure to validate routing behavior and recovery. Monitor real time user measurement. So these are some best practices we can follow with traffic managers. So this is the last slide, I guess. And what are key takeaways with traffic managers? So DNS based global load balancing solution without processing the traffic, and it provides 6 flexible routing methods for any scenarios, and continuous health monitoring with automatic failover, hybrid connectivity across Azure external and on-prem services, cost effective. It provides pay-as-you-go pricing model, and combines with nested profile for sophisticated routing. So with Azure Traffic Manager, we can route smarter, fail less, and scale globally. So this was it about Azure Traffic Manager. I hope you like this video. If you like it, please do check out other videos as well related to DNS and A records, basically DNS records. And I'll see you in the next one.